Okay, so now we're going to talk about exogenic processes, which, of course, get their energy from not within the Earth. Exogenic processes come in four groups: weathering, mass movements, erosion, and deposition. Weathering comes in three forms: physical, chemical, and biological, though some people don't include biological. And we'll talk more about weathering in the next few slides. Mass movements. You can think about rapid mass movements like mud flows or avalanches of debris or landslides, but there are also slow mass movements of material down slopes, such as soil creep or solifluction. There's erosion of various kinds, when something gets picked up and moved by either water or wind or waves or glaciers. And then, of course, deposition. So weathering must take place in situ or in place. So whatever it is, the rock, for example, is broken down into smaller and smaller fragments, but the fragments themselves don't move. Weathering takes place in the unsaturated zone above the water table. And there are two types: there's physical and chemical. Different physical weathering processes include pressure release, like this, where stuff is moved up rock is moved up to the surface, no longer has a bunch of weight on it, and so expands at its joints and forms sheets or exfoliates. There is induced fracture, where either water or salt gets into cracks in the rock, expands, and breaks up the rock. And also heating and cooling and wetting and drying can also induce or cause physical weathering. Chemical weathering involves any chemical reaction that either changes the composition of rock or helps dissolve it and carry it away. Examples include oxidation or rusting, which of course weakens the rock; carbonation and solution, where you get, say, a limestone being dissolved, like this headstone right here; and also hydrolysis, where you get rainwater interacting with silicates and rocks like granite, forming different types of clay. Biological weathering can include either biophysical or biochemical weathering, which is sometimes why it's not its own category. It can include root wedging, where roots of trees and plants get into rocks and wedge them apart, or the production of organic acids from plants, which can cause chemical weathering. Weathering, the type of weathering you get, rather, is heavily dependent on climate. For example, in warm, wet areas, you get a lot of chemical weathering. Think Brazil, for example, you don't see many rock outcrops there. In cooler areas, like Canada's Arctic, you get a lot of mechanical weathering. Things like frost wedging are very important in climates like this. In deserts, you get neither of these, you don't have as much weathering, and then other climates are somewhere in between. Denudation describes any process that involves picking up the weathered debris or even unweathered debris and moving it to a new location. There are two types of denudation: erosion and mass movement. Erosion requires a medium of some kind to move the material, either wind or water or ice. Mass movement simply involves the material moving under the force of gravity. Mud flows are a bit complicated because they are a type of mass movement, but they also have a lot of water involved in them. So it is sort of an open question whether or not they are a result of gravity or a result of flow in some medium. And my take on it is that it's a combination of both, because you need the gravity to move them, but when they get to the flatter part like this, they do spread out sort of in a flowing manner. We'll talk more about mass wasting later, but here are some examples of both slow and fast mass movements. Lastly, we have deposition. It occurs when the medium, whether it's wind, water, or ice, can no longer carry the rock fragments. In the case of wind and water, it depends on the speed. In the case of ice, it just depends on, if it melts or not. And certain mediums, like wind and water, do sort grains based on grain size, because different grains will drop out at different speeds, as we talked about in the water workshop. In the case of ice, because it just melts and drops everything, you get till deposits, which are deposited directly by ice and are unsorted materials of various sizes, anything from clay-sized particles to boulders.